Hi, hello friends. Welcome back to TRB revision series. So as we are discussing about measurements, in measurements we have been completed all important topics from the basics. We have completed till the measurement of voltage, current, power, energy. Next, what we are going to do now is we are going to start from the next topic. Next topic means after completing all this, as I already told you, immediately we are going to start measuring inductance, capacitance, resistance, relative permittivity, Q factor. There are so many things to learn. So let's have a quick revision on everything. So the first one is measurement of RLC. The major topic is keep the measurement of RLC. Now if you are observing, we can measure the value of resistance, inductance, capacitance by using various type of bridges. The first bridge is called DC bridge. The first bridge, what we are calling it as DC bridge. DC bridge name itself, you might have understand that DC, we are using direct current. It works under the principle of DC supply. Here what we will be having is, we will be having a DC galvanometer. This is nothing but a DC galvanometer. It works with the zero frequency. It works with the zero frequency. So DC bridge means we will be using a DC galvanometer, and this DC bridge is usually used to measure only one parameter, that is unknown resistance. So whenever you are looking for only a specific value of resistance, unknown resistance, then we can go ahead with this DC bridge. That name is simply considered as DC galvanometer. That's it. Next, the another type of bridge, that is what we are calling it as AC bridge. As we are observing, it will works under the principle of alternating current. We are going to supply alternating current, and for this, in case if you observe the DC bridge, for DC bridge, what are the types of the sources that we are using? We have only one source, that is what we are calling it as battery. AC bridge can work with the two people. One is with the help of oscillators also we can run the AC bridge. We can also connect a separate AC source externally. So this will be running in terms of with the help of oscillators or AC source, whatever. And next, if you are observing AC bridge, we are having three types of classification under this. What are all those? So the first one, if you observe, vibrational galvanometer. Based on the frequency range, we will be having three type of AC measurement devices. First one is vibrational galvanometer. The first one is vibrational galvanometer. That is the first one. And if you observe, this vibrational galvanometer is having certain range of frequency. The range of frequency for vibrational galvanometer is 500 to 200 Hz. That is the range of vibrational galvanometer. And the second one, the second type of instrument is a telephone detector. Telephone detector. Usually we will be considering headphone. Telephone detector. And if you observe the range of telephone detector, this value lies between 200 Hz to 5 kHz. Telephone detector carry the range of frequency is 200 Hz to 5 kHz. That is 200 Hz to 5000 Hz. First one is vibrational galvanometer, second one is telephone detector, and the last one is tuned amplifier. Last one, what we are calling it as tuned amplifier. What will be the range of tuned amplifier, sir? The frequency range must be greater than 5000 Hz or 5 kHz. That's it. All put together under AC bridge, we will be having three types. One is vibrational galvanometer, second one is telephone detector, and third one is tuned amplifier. So the vibrational galvanometer frequency range is 5 to 200, telephone detector 200 to 5000, tuned amplifier is greater than 5000. That is all you have to remember. And we are seeing that AC bridge is used to measure only a resistor. It works at a zero frequency. Similarly, if you are observing, DC frequency, DC device, DC bridge, DC galvanometer is used to measure only resistor. Whereas if you are observing the AC bridge, this is used to measure capacitor value, inductance value, frequency, quality factor, relative permittivity, D factor. So we can measure all the values with the help of AC bridge. That is the advantage. Now let us see. Before started discussing about the all type of bridges, we will have to go from one by one. The first one, what are the types of the resistance that we are having, and what type of devices that we are using to measure. Let us see the in detailed explanation for the measurement of resistance. Then we will see for all other factors one by one. Now, if you are observing the resistance, first, resistance can be categorized into three parts. First one is low resistance, and the second resistance is medium resistance, and the third resistance value will be categorized as high resistance or large value of resistance. So totally we will be categorizing the range of resistance into three categories. The first one, what is the range of low resistance? If the value of the resistance less than 1 ohm, then we will be considering it as a low resistance. If the range of the resistance lies between, if the range of the resistance lies between, if the value of R lies between exactly from 1 ohm to 100 kilo ohm, if you are going up to 100 kilo ohm, then the correspondent, what we consider as medium resistance. If the value of the resistance is greater than 100 kilo ohm, then we will be considering it as a large resistor. So low resistance means less than 1 ohm. Medium means 1 to 100 kilo ohm. Remember, medium means 1 to 100 kilo ohm. Greater than 100 kilo ohm only will be treated as high or large resistance. Now, if you observe the low resistance means where we are observing, practically where we are observing this low resistance. Usually this low resistance we can measure in transformers winding, our electrical motors, generators, if you are observing ammeter internal resistance, and semiconductor devices in forward bias. So low resistance value we can observe all our machines, especially I can say transformers, transformer winding we can consider, transformer windings, then we can consider alternators, our motors, alternators, our motor, semiconductor devices. Semiconductor device we should consider only forward bias, because in reverse bias the value of the resistance is very high. So semiconductor in forward bias we can consider, that is the best way of approaching it. And transformer windings I have given ammeter internal resistance you can consider, ammeter, internal resistance, all this comes under low resistance. If you are considering medium resistance, if you take some places, especially DC shunt machine, if you observe DC shunt machine field winding, especially if you are focusing on field winding, you would have observed that the value of the resistance is a little bit very large, 100 ohm, 200 ohm, 300 ohm. So those kind of comes, and you can also observe voltmeter resistance. And the best example for medium resistance, one more practical example is human body. We can also consider human body. Then we can consider voltmeter, voltmeter internal resistance, and we will be having heater coils, na? Hall heater coil resistance. All these people will comes under medium resistance category. Now, if you are observing the resistance which is having high range, greater than 100 kilo ohm, the best example, the first one is cable insulation, because insulators only will be having this much amount of resistance. So that is the best example. And if you are taking semiconductor reverse bias, the value of semiconductor reverse bias also will be carrying same amount of large value of resistance. Semiconductors, but they must work under reverse bias. That is very important, because in forward bias the internal resistance offered by the semiconductor is very less. Okay, that's it, sir. Next, if we are playing with the all other components, for an example, so let me complete one more thing. What are all the devices that we are using to measure the value of low resistance, medium resistance, and the large resistance? Let us see. If the value of the resistance is very less, then the best example, the best device that we are going to use is Kelvin double bridge. Most of you might be heard about it. That is the famous one that we are using to measure the value of low resistance. The first one is Kelvin double bridge. That is the best example for the measurement of low resistance. So this device is used to measure the value of the resistance which are having the value of the measurement resistance is less than 1 ohm. That is Kelvin double bridge. And second, one of the most important method is ammeter voltmeter method. Guys, don't get confusion. You might have studied that Under the category of medium resistance measurement, we will have voltmeter ammeter method. That is voltmeter ammeter method. That is not ammeter voltmeter method. There is a difference. Don't get confusion between both. So if you are observing low resistance, Kelvin double bridge, ammeter voltmeter, and some people using the name potentiometer method. That will potentiometer also using we are using to measure the value of low resistance. Potentiometer also used to measure the value of low resistance. Now, if you are focusing on medium resistance, as I told, voltmeter ammeter method is one of the best suitable method. And second one is a substitution. Substitution. You might have observed this word, but you have to remember substitution method. The second one is substitution method. That is another most important one. And third one is the most important and famous method to measure the value of medium resistance is Wheatstone bridge method. Wheatstone. So you will have to remember this. So this all people is used to measure the value of medium resistance. Wheatstone bridge. Next, if you are observing ohm meter method, you might have studied that. There is one more method that is called ohm meter method. So voltmeter, ammeter, substitution method, Wheatstone bridge method, all these methods are used to measure the value of medium resistance. Low means Kelvin double bridge, ammeter, voltmeter method, potentiometer. Sir, what are all the devices that we are having to measure the value of high resistance? Just to recollect once. To measure the value of high resistance, the first one, the most famous method is mega ohm bridge method. The first one is mega ohm bridge method. That is the first one. And the second one is a direct deflection method. The second one is direct deflection method. So the first one is mega ohm and the second one is a direct deflection method. And third one is loss of charge method. So you'll have to remember the next one is loss of charge method. That is the next most important. And the fourth one, the another most important method is Megger method. You might have studied that. Another one is Megger method. So first one is mega ohm method, second one is direct deflection method, and the third one is loss of charge method, and last one is Megger method. So do remember all these four methods are very important to measure the value of large value of resistance. Okay. Now we have completed how to measure the value of resistance, what are the devices that we are using, what are the ranges, everything we have done for resistance. Now let us keep our attention with the next measurement, that is inductance capacitance measurement. So let us go to the next one. What we are going to do now, let us see the methods that are used to measure the value of inductance measurement. I am writing in short. Next one is the measurement of inductance. If we are focusing on the measurement of inductance, we are using so many devices like Maxwell inductance bridge, Maxwell inductance capacitance bridge, Hayes bridge, Owens bridge, Anderson bridge. So we will be using around 5 devices to measure the value of inductance alone. Let us see the first one, what I told, Maxwell inductance bridge. The first one is Maxwell inductance bridge. The first one is Maxwell inductance bridge. If you are observing Maxwell inductance bridge, what you have to remember here is, always remember, see, I will be giving the general structure. Let us take the bridge structure like this, and in between this you can connect your galvanometer. I am just showing you the standard structure that I am going to consider. Now in these 4 branches chromosomes, here I am taking Z1, this one here I am taking Z2, and here I am going to consider Z3, and here I am going to consider Z4. Just to keep the vertical manner. So Z1, Z2, Z3, Z4. That is what I am keeping. Lower numbers, odd number, even number. Just remember like this: Z1, Z3, Z2, Z4. Now after this, what I am going to do is, I will show you. In case of Maxwell inductance bridge, what we are doing is, we are trying to measure the value of unknown inductance. The value of unknown inductance is here. L1 is the unknown inductance. The inductance that is measured in the bridge Z1, that is in the bridge 1, is the unknown inductance. What is the formula to measure the value of unknown inductance? All other value will be given. Inductance in the bridge 2, resistance in the bridge 3, resistance in the bridge 4. All this data will be given. From this directly you can measure the value of unknown inductance in the bridge 1. Similarly, how to measure the value of unknown resistance in the bridge 1? The unknown resistance is the product of R2, R3, bridge 2 resistance, bridge 3 resistance divided by bridge 4 resistance. So what I am saying is, impedance Z1, it is the combination of inductance L1 and R1. All other branches will be given in the exam. they will be giving you the data about Z2, Z4, Z3. You will have to calculate the value of inductance in the first bridge, resistance in the first bridge in Maxwell inductance bridge method. Now, let us discuss about the second method. As I told, the second method is Maxwell inductance capacitance bridge method. So, let us take Maxwell inductance capacitance bridge method. Maxwell inductance capacitance bridge method. So when we are dealing with the second method, Maxwell inductance capacitance bridge method, how to calculate the unknown factor? I will tell you as usual. Maxwell inductance capacitance bridge method also will be playing with the calculation of unknown impedance in the cross sum 1. So in the cross sum 1, what is the formula to calculate the value of R1? The unknown value of R1 will be calculated with the help of R2, R3 divided by R4, and the value of unknown inductance can be calculated with the help of R2, R3. Capacitance will be given in the branch 4. You can directly take all these values and multiply. Do remember the formula, one step you will be getting the answer. This Maxwell inductance capacitance bridge will also helping us to calculate the value of quality factor. Range of quality factor I will tell you later. As of now, just remember the formula. Once you calculate the value of omega L1 and R1, then you can calculate omega into L1 by R1. That is the formula to calculate the quality factor. And this quality factor can also be calculated in terms of cross sum 4. If the capacitance value in the fourth branch and resistance value in the fourth branch will be given, then directly you can measure omega times of R4 into C4. That will also help you to calculate the value of quality factor with the help of Maxwell inductance capacitance bridge method. Now let us discuss about the third method, that is Hurst bridge method. The next one is Hurst bridge method. So let us take the next method to measure the value of inductance, that is Hurst bridge method. So as we are observing Hurst bridge, and standardly take, I have 4 cross sum. As I already told you, I am taking this one is Z1, and this one is Z2, and this one is Z3, this one is Z4, and these two terminal I am directly considering that I am connecting it with the supply, and here I am connecting the galvanometer. Okay, take this same structure again. Inside Z1, Z2, Z3, Z4 can be anything, but just to follow the formula whatever that I am giving. First, we know the balanced condition. Bridge balanced condition means what, sir? Cross product of Z1 into Z4 will always be equal to Z2 into Z3. Correct now? So this is the balanced condition formula. With the help of this balanced condition formula only, we are exploring all unknown data. Now, under bridge balanced condition, AS bridge is helping us to calculate the value of unknown inductance in the coil 1 as usual, unknown capacitance and quality factor. So let me derive the formula. The formula is going to be, once again, the unknown inductance L1. Formula is going to be the product of R2, R3, C4 divided by 1 plus omega square into R4 square into C4 square. This is the formula to calculate the unknown inductance with the help of AS bridge. Now similarly, if they are asking unknown resistance value in the bridge 1, then the formula is going to be omega square into R2, R3, R4 into C4 square. In the denominator, same factor will come, 1 plus omega square into R4 square into C4 square. That's it. This is the formula to explore the value of unknown resistance and unknown inductance. As usual, you can explore the value of quality factor after calculating these values, omega L1 by R1, or else if the value of bridge 4 capacitance value C4 and R4 is given, then also you can explore the value of quality factor as we have discussed in the last case. Okay, and next let us discuss about the next bridge, that is called, let me consider, AS bridge is completed. Now let us discuss about Owen's bridge. So the next method what we are going to discuss here is Owen's bridge. So we have finished Maxwell inductance bridge, Maxwell inductance capacitance bridge, Hayes bridge. Now we are discussing about Owen's bridge. When we are discussing about Owen's bridge, now if you are observing in Owen's bridge, we will also be having capacitance and all other things. As usual, what is the formula to calculate the value of unknown inductance resistance value? Because since we are observing that we are focusing on only the measurement of inductance. Along with that, we are also measuring the unknown resistance offered by the same coil and quality factor. That's it. But our attention only with the measurement of inductance. Owen's bridge formula. Once again, inductance L1 is going to be the product of R2 into R3 into C4. and the resistor value R1 is going to be C4 by C2 into R3. This is the formula to measure the value of unknown inductance in under unknown resistor. Again, if they are asking you to calculate the value of quality factor, after calculating these two, quality factor will become omega L1 by R1, or else you can also calculate the value of quality factor omega into R2 into C2. Here the formula will change. Here we are considering branch impedance, the second branch. Whatever the impedance that will be given here, the second branch C2 and R2. From here also, you can explore the value of quality factor. Okay. Hope you will not forget these two. These methods are very important. And now let us discuss about the one more method. As I told you, we are using 5 methods. One is Maxwell inductance, another one is Maxwell inductance capacitance bridge method, third one is Hayes bridge method, fourth one is Owens bridge method, and the last one is Anderson bridge method. Now let us discuss about the final method to measure the value of inductance. The last one is Anderson bridge method. Let us discuss about Anderson bridge method. So when we are observing the Anderson bridge method, same cross arms you can take. I'm not changing anything. Just to remember once again, the cross arms values are going to be here. I'm considering Z1, here I'm considering Z2, here I'm considering Z3, here I'm considering Z4 by default. So here I'm considering galvanometer, and this is going to be our sinusoidal source. That's it. Now, with this diagram, if you are exploring the value of Anderson, with the help of Anderson, the unknown resistance R1 is going to be the product of R2 into R3 into, sorry, one second. Yeah, so here it will become R2 into R3 divided by the value of R4 minus small r, where it will be given, sir. This small r will be given with the galvanometer. We hope you all know the Anderson bridge. In Anderson bridge, here we will have a capacitor and here we will have a resistor. This resistor will be treated as small r. Similarly, if you are trying to explore the value of unknown inductance, as usual L1, that is going to be C into R3 by R4 in bracket. I will tell you, so write down clearly, R into the formula is R4 plus R3, R4, yeah, R2 will come plus the product of R2 into R4 will come here, R2 into R4. That's it. So this is the formula to explore the value of unknown resistance under unknown inductance. So what we discussed so far, sir, till now, we have been discussed about the various types of methods that is always used to measure the value of unknown inductance value. So while measuring the unknown inductance, it is very important to remember one more factor, that is quality factor. So let us discuss about the another most important term, that is quality factor. So if you are observing the quality factor, we will be having three range. One is quality factor will be less than 1, and quality factor lies between 1 to 10, and quality factor will also become greater than 10. Now in this three range, suppose if the value of quality factor is less than 1, which device? We have seen 5 devices: Anderson bridge, Maxwell inductance bridge, Maxwell inductance capacitance bridge, AS bridge, Owens bridge. Out of these 5 methods, which device is the suitable device to measure the value of low value of the quality factor? The best suitable device is Anderson bridge. Anderson bridge is the one which is used to measure the value of low value of the quality factor. That you must remember. One more question. Similarly, if the quality factor range lies between 1 to 10, this is medium value. This value will be measured with the help of Maxwell inductance capacitance bridge. Maxwell inductance capacitance bridge is used to measure the medium value of the quality factor. If the range of the quality factor is greater than 10, that is high value, then which device will be using? Hayes bridge. Hayes bridge is the one which is used to measure the value of high value of the quality factor. So all put together, the important thing that you must remember is range of the quality factor and the correspondent devices that we are using to measure the value of unknown inductance and unknown quality factors and resistance, everything, whatever that I have given. You must remember all these points are very important point. Okay, sir, this is all about inductance measurements. Let us keep our attention with the next measurement, that is the measurement of capacitance. So the measurement of capacitance. Let us discuss about the measurement of capacitance. So what are all the devices that we are using? As we have been observed, to measure the inductance, we are using 5 devices: Maxwell inductance bridge, Maxwell inductance capacitance bridge, Anderson bridge, Owens bridge, AS bridge. Totally, we are using 5 types of bridges to measure the value of unknown inductance. When it comes to the measurement of capacitance, we are using two devices. Like the two devices are sharing bridge, another one is Desarté bridge. So let me write. So let us go ahead with the Desarté bridge first. So the first one is Desarté bridge. So we will be using Desarté bridge, and the second one is sharing bridge. The second one is sharing bridge. These two devices are very important. Repeat one more time, because name itself questions will come. Which device is used to measure the value of capacitance? In four options, they will give either one option, Desarté or sharing bridge. So these two devices are used to measure the value of unknown capacitance. Now let us discuss about Desarté bridge. As usual, to avoid the confusion, always take the bridges in the same structure that I have given, because I am just standardly following this in order to give the clarity to all of you. Now let us take the same cross sums with the same impedance, Z1, Z2, Z3, Z4. This is our structure. Now, from here, if you are measuring the value of unknown capacitor, where is the unknown capacitor? Once again, in the branch 1, you will have your unknown capacitor. What is the formula to calculate the value of unknown capacitance, and which device, which method we are going to discuss? The first one is Desarté bridge method. Let us see with the help of Desarté how to measure the value of unknown capacitor. So, let me write down here. The unknown capacitor C1 formula is going to be branch 2 capacitor will be given, branch 4 resistance will be given, branch 3 resistance will be given. So with the help of this, directly you can measure the value of unknown capacitance C1 by using Desarté bridge. Now the next one here, if you are observing the another method, what I told you is sharing bridge. Now in the Desarté bridge, there are a few more questions will be framed. That is the concept of if you are connecting a practical capacitor, how to measure the value of loss of tangent and the D factor. I will tell you. If you are requested to calculate the derating factor or dissipation factor, they will mention, they will write down, they will give the full name. Dissipation factor or derating factor. So what is the formula to calculate the derating factor or dissipation factor? If this is the question, what you can do is here the formula is derating factor is equal to simply tan delta. And this tan delta formula, that will be equal to omega into R into C, that is loss of tangent. So this data will be given. So now if they are asking you to calculate the value of dissipation factor or derating factor, directly explore the value of tan delta, that is loss of tangent, that is nothing but omega RC. So derating factor is nothing but the product of omega RC, that you must remember. Next, the another bridge. This is all about Desarté bridge. The second bridge is sharing bridge. With the help of sharing bridge also, we can measure the value of derating factor and unknown capacitor value. Let us see the formula to measure this. That is one of the most important method, that is sharing bridge. Let us discuss about sharing bridge. So if you are discussing about sharing bridge, what is the formula? Structure is remain same. I am not going to change the structure. The structure is remain same. In the same structure, how to calculate the unknown capacitor C1? For that, use the same formula. The unknown formula will be R4 by R3 into the capacitor value will become C2 only. It is similar to Desarté bridge. So the formula will not change to calculate the value of unknown capacitor. But here, unknown resistance also will be given in the branch 1. That unknown resistance you can calculate with the help of capacitance C4 and C2 resistor value R3. This will help you to calculate the value of unknown resistor. Next, you will be requested to calculate the value of derating factor. Once you done this, then you will have to calculate the value of derating factor. The formula to explore the value of derating factor is omega into R4 into C4. You can calculate, or you can also calculate it with the help of omega into R1 into C1. That's it. So here I am using small. Okay, use the capital one. Nothing is wrong. So that is capital R1. That's it. So this is how we are measuring the value of unknown capacitance with the help of sharing bridge and the Desarté bridge. Sir, you must remember both of these methods, because they all are very important. Okay. And apart from this, we will be using one more device, the special device that is used to measure the value of bridge. That bridge is used to measure the frequency, unknown frequency. Anyone of you remember? There is one famous device which is used to measure the unknown frequency. Yes, that is Wien bridge. So now I will teach you what is the purpose. The special application Wien bridge is used to measure the value of unknown frequency. Is used to measure the value of unknown frequency. So it is used to measure the value of unknown frequency. Now, what is the formula? You can take the same bridge structure. I am not going to change the bridge structure. So, as usual, they will give 4 cross sums. In the 4 cross sums, they will give all the data clearly. Z1, Z2, Z3, Z4. All the bridges will be given, and here we are connecting our measurement device, and here will be our external source that we are connecting here. Now, in Wien bridge, what is the formula to calculate the value of unknown capacitor? Sorry, unknown frequency. The formula is going to be 1 upon 2 pi into square root of R1 into R2, C1 into C2. Do remember? So, from the branch 1, here you will have to take the value of R1 and C1, and from here you will have to take the value of R2 and C2. Then directly substitute to obtain the value of frequency. Under balanced bridge condition, there will be one more thing will be satisfied. That is, if you are taking the ratio between the bridge 1 and bridge 2 resistor R1 by R2 and add bridge 2 given capacitance, this total value will be equal to the ratio of bridge 3 versus bridge 4. 1 to 2, 3 to 4. In between, we will have 1 to 2, 2 to 1 capacitor. So by adding this, the total value will be equal to R by 4. From here also, one more question will be framed. Under balanced condition, this ratio condition also will be satisfied. Hope you understand, sir. That's it. So these all parameters are very important. If you are observing the Wien bridge, actually the Wien bridge we are using. So first of all, it is, as I told you, it will be used to measure the value of certain frequency. Then you should raise the question: what will be the range of the frequency? It is actually used to measure the range of frequency from 100 Hz to 100 kilohertz. That is the first thing that you must remember about Wien bridge. Range of frequency for Wien bridge is 100 Hz to 100 kilohertz. So that is the best suitable range. And next thing is, one more question will be framed. Suppose I am having a signal which is having harmonics. I am having a signal which is having harmonics. Is it possible to measure the frequency of a signal which is contains harmonics also? In that case, you will have to say no. Wien bridge is not used to measure the signal which is mixed up with the harmonics also. It is very difficult to measure the frequency with the help of, because what will happen is, if a signal is mixed up with the harmonics, then bridge balanced condition may not be obtained. It is very difficult to obtain the achieve the balanced condition of the bridge. So balanced condition will not be possible when the signal is contains harmonics. In such a case, we are not Wien bridge may not be help us to calculate the value of unknown frequency. So you will have to pass only fundamental frequency signal, and the frequency range can be 100 Hz to 100 kilohertz, and you can pass and you can explore the value of frequency. Remember one more thing, sometimes they will tell the value of R1 and R2 will be equal to each other, C1 and C2 will be equal to each other. Then the formula will become 1 upon 2 pi into square root of RC. R is nothing but either R1 or R2, C is nothing but either C1 or C2. That's it. So that is how we are calculating all these things. Now here there are certain sensitivity. From there questions will be directly asked in the examination. Now if you observe the exam questions, repeatedly asked the question is, calculate the current sensitivity of the bridge, calculate the voltage sensitivity of the bridge, galvanometer, calculate the bridge sensitivity. How to measure the current sensitivity, voltage sensitivity, bridge sensitivity when it is asked in the exam. So let us discuss about the various type of sensitivities that you must read when it is asked in the exam. So the first one, what they will ask is voltage. Sorry, let us go ahead with the current sensitivity. The first one is, find the current sensitivity of the galvanometer. That is the question. Current sensitivity of the galvanometer. So sensitivity is nothing but variation in deflection. That is change in output with respect to change in input. If you are observing, we are discussing about meter. In the meter, the output is deflection. Your meter is moving from one point to another point. So the change in output divided by change in input. What is your input? Current sensitivity means with respect to galvanometer current, we are exploring the value of current sensitivity. So theta by Ig. That is the correct answer for this. And its unit will be given. Its unit will be given in the exam. Anyway, you can keep, see, this is, it is in deflection. But here it will be represented in meter. So here it will be represented in meter. So maybe in the range of millimeter to microampere. Current rating will be very less, na? So that is in general, but whatever the data that they are giving in the exam, that you can follow. But in general, current sensitivity means it is the ratio between change in output with respect to input. Change in output is the deflection. With respect to input is, in case of current sensitivity, you will have to consider galvanometer current. Current that is flowing through the galvanometer. The next one is voltage sensitivity. So now you can easily guess this. When it is comes to voltage sensitivity, we can easily identify how to define this. Voltage sensitivity is nothing but change in deflection with respect to the voltage. Change in deflection with respect to voltage. As usual, this is going to be millimeter per volt. That's it, na sir. So that is voltage sensitivity. And next what they will ask is the final one is bridge sensitivity. Bridge means on the bridge we will be having resistance. So with respect to the change in resistance, we will be exploring the value of bridge sensitivity. If they are asking bridge sensitivity, change in output with respect to change in bridge. Change in bridge means what will be the change of resistance with respect to total value of the resistor. So its unit is going to be millimeter as usual per ohm. So ohm will get cancelled here. That's why it will not come. So it will be in millimeter. That's it. So now we have explored the current sensitivity, voltage sensitivity, bridge sensitivity. Correct, na sir? So all you have to remember is it is very important to remember all these formulas, whatever that I have given. The next question here they will ask, what is the maximum bridge sensitivity? Maximum bridge sensitivity. If they are asking you to explore the value of maximum bridge sensitivity, how will you explore maximum bridge sensitivity? How to explore the maximum bridge sensitivity, sir? That is very simple. I will tell you. The formula will become as usual. See, we are having the formula for voltage sensitivity. Let me consider SV. The voltage sensitivity formula is going to be SV. And here what we are having theta by V. From this formula, if you are exploring the value of theta, that will be V into SV. Yes or no? Sensitivity representation is SV. If SV equal to theta by V, then theta can be replaced by V into SV. So maximum bridge sensitivity will become, replace this theta by S into V. So all put together the formula will become V into SV by 4. This is the formula to obtain the maximum bridge sensitivity. Don't forget, this is a very important formula. Understand, sir? So in our today class, we have completed the measurement of inductance, measurement of capacitance, measurement of resistance, measurement of unknown frequency, measurement of quality factor. We have seen all these things. Then we have seen how to calculate the value of sensitivity of the galvanometer when it is being asked in the examination. Next what we are going to discuss about the last one, that is potentiometer, the next method. As we are observing, already I told you potentiometer is used to measure the value of low resistance. Correct, na sir? But in potentiometer, what type of questions will be asked in the examination? That is what you must remember regarding potentiometer. In potentiometer, based on the length, we will be exploring the value of unknown voltage. So what you have to remember is the voltage measurement is directly proportional to length of the wire, length of the slide wire that we are considering. So here from the length of the slide wire, if they are asking you to calculate, what they will do is initial length is L1, the new length is L2, initial voltage is E1, then what is the value of E2? All you have to do is just to take the ratio between these two, that will give you the value of unknown voltage. Especially we are using the potentiometer to measure the value of, potentiometer is also used to measure the value of unknown voltage. It is also used to measure the value of unknown voltage. We have seen how to measure the value of resistance, inductance, capacitance, unknown quality factor, frequency. If an unknown voltage will be given, how an unknown voltage will be predicted with the help of potentiometer? Since the value of the induced voltage is directly proportional to length of the slide wire, so based on this, from this what I can define is the new voltage divided by old voltage equal to new length of the slide wire divided by old length of the slide wire. By using this condition, you can easily explore the new induced voltage when it is asked in the examination. Okay, next, the thing is, we have done all these things. We have completed the potentiometer. Now with this, we have completed all the measurements like capacitance, resistance, quality factor, then range of quality factor, its correspondent device. What are the devices that we are using for resistor, inductor, capacitor, low resistance, medium resistance, high resistance. Then we have seen unknown frequency calculation, unknown induced EMF calculation. We have done so many calculations revision today. So in the next class, we are going to start the next most important device, that is instrument transformer, one of the most important device. Repeatedly asked the question. Current transformer turns ratio error, phase angle error. That question is repeatedly framed in the exam. And next important area is CRO, cathode ray oscilloscope. That is one of the most important part. So these two parts we will cover in the next class. If it is possible in the next class, we will also complete analog and the electronic, digital electronic devices, and we will also complete Q meter. So we will have to complete Q meter is balanced, and we will have to complete digital electronic devices. Okay, with this we will be completing the measurement. So in the next class we will discuss about rest of all things. This is all for this lecture. If you have any doubts further, you can ask your doubts in the comment section. Answer will be shortly given. Okay, thank you all.